What's up, YouTube? Some R2. I'll take a look at all the updated stuff we have found about water and the universe and what it all might mean. There's quite a bit of information here. I'm not going to read all of it. I'll post all the links, though. There's quite a bit of interesting excerpts. Let's see here. Researchers looking for signs of life elsewhere in the universe often start by looking for one key ingredient necessary to complex life as we know it: water. Just 750 light years away, they found quite a bit of it, spewing from poles of young stars. Sun-like star that is blasting jets of H2O into interstellar space at 124,000 miles an hour. This discovery is interesting in a number of levels. For one, it indicates that throughout the universe, young protostars could be distributing vast quantities of water, potentially seeding life elsewhere. But it also sheds light on the formation of our own sun and the role that water may have played in the formation of our own planet. So there's quite a bit of information about water everywhere: supersonic hail, seed star systems, and even found stars that are as cold as as hot as a fresh cup of coffee, around about 97 degrees Fahrenheit at its surface. And this is really similar to, we can take a look at some photographs here. We'll take a look here at what's actually happening. The solar wind and coronal mass ejections, if you look those up, they are the same thing. Mass is matter, high charged energy of matter, and that matter is water, and it's in an evaporated state. Let's take a look here at some of this other evidence. Okay, let's go down here. It says water vanishes only to reappear. Located in the northern constellation of Perseus, the protostar is no more than 100,000 years old and remains swaddled in a large cloud, gas and dust from which the star was born. Using an infrared instrument, the European Space Agency, researchers are able to peer through the cloud and detect telltale light signatures of hydrogen and oxygen atoms, the building blocks of water, moving on and around the star. After tracing the paths of these atoms, the team concluded that the water forms on the star where temperatures are a few thousand degrees, but once the droplet enters the outer spewing jets of gas, 180,000 degrees, temperatures blast the water back into a gaseous form. Once the hot gas hits much cooler surrounding material at about 5,000 times the distance from sun to earth, they decelerate, creating a shock front where the gas cools down rapidly, condensing and reforming as water again. Okay, we'll look at some photographs that show, that it's this zone where water is evaporated, where life shows up. And anything with a magnetic field is going to cause that to condense again. So therefore, that's what, this is what's happening. I mean, it's happening all over our planet, right in front of our eyes. We can take a look at the heliosphere of our own heliosphere, the outer Oort cloud and whatnot. And this basic process, same thing's happening here is what's happening in the atmosphere of our Earth. You have water being, turned into evaporated or used as electrolysis. They're both the same thing. And in the spot where water is in its state capable of being in all, 4 states actually: solid, ice, liquid, water, gas, and even the plasma form where we see lightning in our own atmosphere. It also shows up all through the same spot, as above, so below. Not necessarily a perfect mirror, but quite a remarkable reflection of one another. This water comes out and condenses at our Oort cloud, and yes, comets are, a lot of comets are made of water. Not all of them are made of water. Anything can fly towards that sun is going to have electric discharge, whether it be a planet or an ice ball or whatever you want it to be. And the fact that the ones that they have studied may actually been water versus the ones that we've seen that may actually not be water. So comets or any object that's flying into our solar system is going to have a tail and an electrical discharge. And the fact that this whole area is evaporated moisture, then anything that flies through it's going to have, at an increased accelerated rate, going to have a tail. So I was hoping that might clear some stuff up. Maybe that'll help everybody see, this whole thing is just pretty, it's over and over and over. It's not really a question of, is there life anywhere else? It's almost a given as to how much life there is out there. Here we're showing water on the moon, and actually find it in the bottom of a crater, and ice, of course, but I mean that shows that there's a water table under the surface here, and they're going to find the same thing they found on Mars. Let's see here. Mars, until now, Earth was the only planet known to have vast reservoirs of water in its interior. Scientists analyzing the water content of 2 Martian meteors originated from inside the red planet. They found that the amount of water in places of the Martian mantle is vastly larger than that previously estimated and similar to that of Earth. This result not only affects what we know about the geological history of Mars, but also has implications of how water got to the Martian surface. The data raised the possibility that Mars could have sustained life. So you can read all this too. The fact is, water's everywhere. It's in everything. It's what it's made of. Peace and love. Big heads up.